Hi everyone, welcome to our video on finding the derivative using the definition where we have a square root function. Okay, so whenever you have the definition, whenever you have to use the definition to find the derivative, we should set it up. Remember that it is the instantaneous rate of change, which is our limit as h goes to 0 of, now again, it's usually f of x plus h, but in this problem it's using s. So we'll use s, and instead of x plus h, we see it's t is the other variable, so we'll do t plus h. And then minus s of t like that. Okay, so we'll always just make the adjustment based on whatever letters they use. And then now I'm just going to sub these in. Let's do this in one big line as well. I don't think we'll need scratch work for this. You'll see why very soon, where we've got our s of t plus h is plugging in the t right here into our square root function. So we'd have 4 times t plus h and then plus 5. And then we have our minus s of t is just the original function there. So the 4t plus 5 like that. And then it's still all over h. Okay, and it looks like inside the blue we could distribute. We could simplify a little bit there. So let's rewrite it as the limit as h goes to 0 of the square root of 4t plus 4h plus 5 minus the square root of 4t plus 5. Okay, so that's the first step where we evaluate the functions as far as we can and then simplify as far as we can, and that's as good as it looks like it gets, still over h. And then now we want to continue simplifying, and we just use one of the strategies that we've used before with limits. Remember, if there's square roots involved, that we will want to multiply both the top and bottom of this expression by the conjugate. And so the conjugate is just rewriting these two terms the same way you see them. So 4t plus 4h plus 5, but just changing the middle sign. So plus, and then still 4t plus 5 under the square root. Okay, so I copied the first and second term exactly the same. And then I just made sure to change the middle sign. And then I think, well, whatever I do to the top of a fraction, I need to do to the bottom. So we'll multiply it by the same thing down below. Like that. There we go. Okay, so we have our limit set up. And then now I want to FOIL it out up top. So FOIL the top. However, we have a special rule here when we multiply by the conjugate. So when we multiply by the conjugate, the O and the I, the outside and the inside terms, will zero each other out. Okay, so the two middle terms, so we really only have to multiply the first and the last. Okay, so the outside, inside, so when multiplying by conjugate, the middle terms, the O and the I, would zero out. Middle, zero out. And we really just have to multiply the first terms together and multiply the last terms together. Okay, so all we really have to do, let's go ahead and say that, multiply first together and last together. So we can skip a middle step. So that's the whole point of the conjugate, is to get rid of those middle terms. And so when we do, so this is what it would look like. So the limit as h goes to 0. All right, so our first terms when multiplied, well, square root times the square root, it's the same square root, would mean that the square root just goes away and you're left with the 4t plus 4h plus 5. Now the outside and the inside terms would zero each other out. I'm going to put minus 0 as a placeholder, and I'm just going to try to say it and visualize it instead of writing it all the way out, because these are pretty weird expressions. But notice, if we were to multiply the outside terms, this square root would times this square root, and it would be positive. So weird square root times another weird square root. And then when we multiply the inside terms, well, it is the same square root times the same square root that we just did. However, it's a minus in front this time. So it's the same thing minus itself. The same thing minus itself is 0. Okay, so that's why we can skip those outside and inside. Let me just say it in red. So those would be 0. Okay, and then now I just really have to multiply the last terms, which is a negative and a positive, so it would be minus. The same thing times itself under a square root is just the 4t plus 5. Again, and use the parentheses. So if you had an expression inside, so square roots do have implied parentheses. Again, they usually don't show them, but they are there. So once the square root is multiplied, we definitely need them because this minus will distribute in the next step. Okay, anyway, but before we simplify that next step, let's go ahead and just write out our denominator, which is just copy and pasting what's above in that denominator. Okay, so there's our limit so far. And then we say, well, minus 0 is gone. This minus would distribute. So it's going to change those to negatives. And so what we have now is the limit as h goes to 0 of 4t plus 4h plus 5. And I don't need those parentheses anymore either because there's really a positive in front that distributes. So I don't need the parentheses anymore. And then minus 0 I don't need to write. But let's go ahead and write minus 4t and minus 5. Like that. And then in the denominator, I still have the same old thing. So 4t plus 4h plus 5 under square root plus the square root of 4t plus 5 under square root. And then now I'm looking at it, and well, from previous problems, we probably know the pattern. We could see, oh, 4t minus 4t is 0. And then our positive 5 minus 5 is also 0. So we're left with only an h term, and that's what should happen. So this becomes the limit as h goes to 0 of just 4h over h times the square root of 4t plus 4h plus 5 plus the square root of 4t plus 5. Okay, and I keep underestimating the fraction bar, but there we go. Okay, and then this is looking good. So our main goal in these limit problems is to eventually cancel out these h's, which we did. Okay, so that's good. Okay, so this h in the denominator should always cancel eventually. And then we're left with the limit as h goes to 0 of 4 over just this square root plus that square root. So the square root of 4t plus 4h plus 5 plus the square root of 4t plus 5. Okay, so that's what that looks like. And then now we can plug in the h as 0 into the 1h that we have. And then now we are doing the limit, so I can write this as just 4 over the square root of 4t plus, well, this 4h, I would just say this does become just 0. So it really is 4t plus 5 is the only thing that's in the square root now. And then we still have plus the square root of 4t plus 5. Okay, so it looks like we have the same thing added to itself. So that means we have two of them. So we have 4 over 2 times the square root of 4t plus 5. Just like if this was x and x, so x plus x would be 2 x's. So the same thing plus itself is 2 of them. And then, well, we could see 4 and 2 do divide a little bit. I would have 2 left over up top over the square root of 4t plus 5 down below. Oops, and I don't really need that parenthesis. Let me at least fix that there. Okay, so that's our final answer for this derivative. Okay, so we just found it, and I kind of went too far on this with the room. So wrote a little too big here, I think, in these two steps, so sorry about that. Hopefully write a little smaller, but let's go ahead and finalize it. I'll do it in this small margin on the next page. So we have s prime of t, so that's what we found. Again, I usually don't write it the whole way, I just have equals. So s prime of t is our final answer there. So I'm just going to squeeze it into this next margin. Hopefully you had enough room on your page. Okay, so it was 2 over the square root of 4t plus 5. So that was that portion. And then they did ask for one other thing. They said find s prime of 1. Well, all you have to do is plug 1 in to our equation that we just found. Okay, so s prime of 1 is 2 over 4 times 1 plus 5, all under the square root like that. Well, 4 times 1 is 4, plus 5 is 9. So we have 2 over the square root of 9. And well, the square root of 9 is 2/3. There we go. So that's that derivative answer right there, which again would represent really the slope at that t value of 1. Okay, so that's the instantaneous rate of change of our function at t equals 1. Okay, so anyway, so that's it. So I mean, this is getting near the end of doing these types of limits. Okay, so hang in there. It's a whole lot of them though for a while, and we've been doing them. So be patient with them. Always be patient with these limits. Okay, so take your time with it. Be organized. Okay, other than that though, thank you for watching, and we will see you next time.